In this video, we'll begin to look at some of the word problems that come up when we have variables on both sides of the equation. So one of the important types of problems are these distance problems. And these distance problems utilize the formula distance equals rate times time. And so it goes like this. A boat leaves New Orleans, travels upstream on the Mississippi River for 4 hours. The return trip takes only 2.8 hours because the boat travels 3 miles per hour faster downstream due to the current. How far does the boat travel upstream? So with these types of problems, I'm always going to set up a little table. And there are two parts to these problems. One is with the boat going upstream, and one is with the boat coming downstream. Then for each column, so I'll put each of those in a row, for each column I'm going to have distance, then equals rate times time. So one column will be for distance, one for rate, and one for time. And then I'm going to fill in the information based on what the problem tells me. So it says that the boat leaves New Orleans traveling upstream. So we're working on the first row for 4 hours. All right, so we'll put in 4 hours under time. The return trip takes only 2.8 hours. So coming downstream is 2.8 hours. Because the boat travels 3 miles per hour faster downstream due to the current. So we don't know what the rate is going upstream, but we do know that the rate is 3 miles an hour faster coming downstream. Now it doesn't say anything about the distance, except we know that the distance traveling upstream is the same as the distance traveling downstream. There's nothing to lead us to believe that the distances aren't the same. So we can simply say whatever that distance is doesn't really matter. And from this I can make two equations. And the first equation is that distance is equal to x times 4, but we'll write it as 4x. So that's our upstream equation. Then downstream we have distance equals, now you have to write this very carefully, it's 2.8, and then because the rate is x plus 3, we have to put that in parentheses. If we don't put the parentheses, we'll get that wrong. And that's our downstream equation. Now since both of these give us the same distance, we can then set these two equations equal to each other because they're both distance and they are referring to the same thing. So I'll set up the equation 4x is equal to 2.8 times the quantity x plus 3. Alright, so now we have an equation and we know what to do here. First we're going to distribute on the right side. So we need 2.8 times x. We'll bring down the 4x is equal to 2.8x. Oops. And 2.8 times 3 is 8.4. 2 times 3 is 6. 0.8 times 3 is 2.4. 6 plus 2.4 is 8.4. So we know what to do now. We're going to move our variables over to the left. So I'm going to subtract 2.8x from both sides, minus 2.8x, and that leaves me with 1.2x on the left is equal to 8.4 on the right. And so x is equal to 7, and we want to think about what x means there. That is miles per hour. So the rate going upstream is 7 miles an hour, and the rate coming downstream 3 miles an hour faster is 10 miles per hour. But we have to be careful because neither of those is what we are trying to figure out in this problem. What we're trying to figure out is how far does the boat travel upstream. And so either equation should give us the same value. And so I'm going to use over here, since distance is equal to 4x, then that's equal to 4 times 7, which is 28 miles, and we should be able to get distances 2.8 times x plus 3, which is 10, is also 28 miles. So we can see that the distance traveled is the same, both going up and coming back. So we would write the boat travels 28 miles upstream. And that's the answer to our question there. Okay, so if you need to rewind, replay, to review this problem, go ahead. I'm going to scroll up and do the monitoring progress problem from this section of the chapter. Okay, so a boat travels upstream on the Mississippi River for 3.5 hours. The return trip only takes 2.5 hours because the boat travels 2 miles per hour faster downstream due to the current. How far does the boat travel upstream? A very similar problem to the one that we just worked on. So I'm going to set up my table. And once again, I have upstream. And it says a return trip, so I can either write downstream or return trip. And I have distance equals rate times time. And I'm ready to fill in some values here. All right, we know that the trip upstream takes 3.5 hours. So I'm going to write 3.5 in there. The return trip takes only 2.5 hours. So we know both of the times. Because the boat travels 2 miles per hour faster downstream. Again, we don't know how fast it's going upstream, but we do know that downstream is 2 miles an hour faster. Once again, we don't know the distance, but we do know that the two distances are equal to each other. And we're ready to set up two equations. D is equal to 3.5x and D is equal to 2.5. Again, remember, we have to put the x plus 2 in parentheses. The first is the upstream equation, and the second is the return trip equation. All right, since these both equal the same distance, or the two distances are equal to each other, we can set these equations equal to one another, and we have 3.5x is equal to 2.5 times the quantity x plus 2, and we're going to distribute on the right. Left side stays the same for now, and we have 2.5x, then 2 times 2.5, get your calculator out, we have 5, and so we're going to move the variables to the left by subtracting 2.5x from both sides, leaving an x equals 5. So that means that going upstream, the boat was traveling 5 miles per hour. Since on the return trip we have the current causing the boat to move faster downstream, we know that that's x plus 2, or 7 miles per hour. Once again, though, neither of these are what we're trying to figure out. We need to figure out how far the boat travels upstream. So we should be able to use either equation. So distance is 3.5 times x, and that should give us 17.5 miles. We'll check the other equation just to make sure that that was correct. So we have 2.5 times 7, and 2 times 7 is 14. Half of 7 is 3.5, so we also get 17.5 miles coming back. And so the answer to the question is the boat traveled 17.5 miles upstream. And that'll do it for these example word problems in section 1.3.